Lesson 16, Probability of Simple Events. A few things to remember from last semester is that probability can be written as a fraction, decimal, or percent. Fractions are typically the easiest to write, and you'll see when we do a few examples. The total will always go on the bottom, and become familiar with the deck of cards if you're not already, because they will ask you a lot of deck of card questions. So the more familiar you are, the better you will do. So here is a picture of a standard deck of cards. So there are 52 total cards. Okay, 52 total. So that's something you can remember right off the bat. There's 52 total cards in a deck. There are 4 suits: clubs, spades, hearts, and diamonds. You have ace, 2 through 10, and then 3 face cards, so jack, queen, and king. Alright, so experimental probability. Experimental probability is where you take the total number of trials. So remember how I told you total will go on your bottom? Total will always go on the bottom. So that your total number of trials, which is how many total times you did your experiment, and then the number in your numerator or on top will be the number of times that specific event occurred. So depending on what the question is asking, you might have a different answer here. So here we have an experimental probability, okay, and I want to know what is the experimental probability of drawing hearts. Okay, well, remember that I need to add all 4 of these together. This will give me my total. So my total is going to be to add all of these numbers together, the 16, 22, 24, and 18. When I'm adding all 4 of these together, that is telling me how many times I did this experiment, or the total number of trials. So when I add all of those together, I get 80. So 80 is my total, so that means 80 is going to go on bottom. Now, the question is asking me, what's the experimental probability of drawing hearts, right? So if I look up here where my suit says hearts, I drew that a total of 16 times. So I would have 16 over 80. The next question says, what's the experimental probability of drawing diamonds? Okay, well, my total number is still 80. That doesn't change. When I look at diamonds, I drew diamonds 22 times. So I have 22 over 80. Now for these, you can simplify your fractions if you would like to. You do not always have to simplify with probability, which is what is nice. And last question, what is the probability of drawing clubs? So here I have clubs. I drew that 18 out of 80 total trials. Alright, so here we have an experiment that involves drawing a card from a standard deck, okay, recording its color and then returning it back to the deck. The experiment was performed 60 times. So it tells me right here, this is the total. It was performed 60 times, which means that my total here is 60. So 60 is going to go on bottom. And I want to know, what is the experimental probability of drawing a red card? Well, if I look here at the color red, it was drawn a total of 36 times, which means my experimental probability is 36 over 60. Now let's move on to theoretical probability. So again, like experimental, your total is still in the bottom, except now it's the total number of possible outcomes. Meaning, if I were to roll a normal dice, there are 6 different sides to a dice. So that means I have 6 different possible outcomes. And the number of ways an event can occur, again, is similar to before. How many of those options do I have? So here's my option of rolling a normal dice. Well, first let's think, how many total sides are there? We just said there are 6 sides, right? Because I could roll a 1, 2, 3, 4, 5, or 6. I want to know, what are the different options I could land on. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. What is the theoretical probability of rolling a 3? Okay, so there are 6 total options that I could roll, right? So that means 6 is the total, so I'm going to put 6 on the bottom. Now, a probability of rolling a 3. When I look at the different options that I could roll, only one of them is a 3. So that means I can have a 1 out of 6 chance of rolling a 3. What is the theoretical probability of rolling an even number? Okay. So if I still have 6 total options, right, because I'm still rolling a dice, I still only have 6 sides, but I have 1, 2, 3 even numbers. So this would be 3 out of 6, or you could simplify this to 1/2. What is the theoretical probability of drawing a red king from a standard deck of cards? Here, remember that a standard deck of cards has 52, right? So there's 52 total options, and I need to know how many of those 52 are red kings. Well, if I go all the way back to that picture that I have here, I see 1 red king and 2 red kings. Okay, I can either draw a king of hearts or a king of diamonds. The other 2 kings are black, so those don't count because the question is asking us for red kings. Which means that on this problem here, I would have a 2 out of 52 chance of drawing a red king. Which event is most likely to occur? Alright, so we're going to figure out the probability of all these to see which one has the highest. Rolling a 5 on a standard dice. Well, I have 6 total outcomes, right, because there's 6 sides to a dice, and only one of those numbers is a 5, so I have 1 out of 6 chance. Drawing a face card from a standard deck of cards. Remember, a standard deck of cards has 52 cards in it, and if it's a face card, that's Jack, Queen, or King, so that's 3. And remember, there are 4 suits, so I'm going to take 3 times 4, which is going to give me 12. And drawing a spade from a standard deck of cards. So remember, I have 52, okay, total cards. And if I were to count the total number of spades, which is just 1 suit, that would be a total of 13. This would simplify to 1/4. We'll come back and simplify this top one in a second. And then rolling an odd number on a standard dice. Okay, well, I have 6 total sides on my dice, and for odd numbers, I could roll a 1, 3, or 5, which would be 3 out of 6, or 1/2. Now, when you are trying to determine which event is most likely to occur, we want the probability that is the highest, right? So let's simplify all of these fractions here. 12 and 52, let's divide it just by 2 first. So 12 divided by 2 is 6. 52 divided by 2 is going to give me, let's see, 26. I can simplify this again, divide it by 2 again. So that would give me 3 over 13. And I can't simplify that anymore. So now let's kind of think about these as a decimal. If you are unsure about what to do at this point, let me show you this really quick. So I'm pulling open Desmos, and what I'm going to do in Desmos is I'm going to take all of these fractions and type them in. So I have 1/6, I have 3/13, I have 1/4, and I have 1/2. So looking at the decimals might make it a little bit easier. By looking at these decimals, I can see that 1/2 has the largest probability, which means that 1/2 has the biggest decimal, so that event is most likely to occur. So D, rolling a standard dice. Which event is least likely to occur? Now, if you notice, these are exactly the same from last time, right? Rolling a 3, rolling an even. Actually, they're slightly different, but they'll give you the same fractions. This would be 1 out of 6. 1/2, 1/4, and 3 over 13. So 1/6 was the smallest. Okay, so if I look at 1/6 here, I have 0.16 repeating. So 1/6 is the least likely because it is the smallest decimal. So probability scale. So 0 means it is literally impossible for that event to occur. 1 or 100% means that there is no other option. That event is going to occur 100% of the time. And 50% means that, well, you have a 50-50 chance of that happening. It's like rolling a dice and getting an even or an odd. There's a 50-50 chance of that happening. Anywhere in between is going to be unlikely or likely depending on what your odds are. So, which answer best describes the likelihood of drawing a card that is a black or face card from a standard deck? Well, if you think about it, half of my cards are black cards, but I also have some face cards that are red, right? I have some face cards that are also red and black. So that means that instead of just having a 50-50 chance, I would say this is likely to occur because I have 6 face cards that I can include plus half of my deck, because half of my deck will be black cards. Which answer best describes the likelihood of rolling a die and resulting in an odd number or multiple of 2? So I have 1, 2, 3, 4, 5, 6, right? Those are my dice. I can roll an odd number, which would be 1, 3, or 5, or a number that is a multiple of 2, which means you can divide it by 2. So if I look at 2, 4, and 6, I can divide all of those by 2, which means that it is certain, because every single option that I have has been chosen, right? All the evens and all the odds, I can pick any one of those. Regardless of what number I roll, it will count. So that is all that I have. If you have any other questions or would like some extra help, please let me know. Other than that, have a wonderful rest of your day.